In 2017, our solar system received a visitor from interstellar space. This visitor was an object unlike any we had ever seen before. It was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. Oumuamua was the first known object from another star system to pass through our own. Its arrival sparked intense curiosity among astronomers and the public alike. What was this strange object? Where did it come from? And what could it tell us about the universe beyond our sun? The discovery of Oumuamua was made possible by the Pan-STARRS 1 telescope in Hawaii. On October 19, 2017, Pan-STARRS detected a faint point of light moving rapidly across the background stars. The object's speed and trajectory quickly revealed that it was not bound to our sun. It was, in fact, an interstellar interloper. Astronomers around the world trained their telescopes on Oumuamua, eager to learn as much as they could about this mysterious visitor before it disappeared from view. One of the most striking things about Oumuamua was its unusual shape. Observations revealed that it was highly elongated, resembling a giant cigar or a cosmic needle. Its estimated length was at least 10 times its width, making it unlike any asteroid or comet ever observed in our solar system. This peculiar shape immediately sparked debate and speculation. Adding to the intrigue was Oumuamua's surprisingly rapid rotation. Observations showed that its brightness varied significantly over time, suggesting that it was tumbling end over end as it traveled through space. This rapid rotation further indicated that Oumuamua was a solid object rather than a loose collection of debris. The object's unusual shape and rotation posed challenges for scientists trying to determine its composition. However, its reddish hue hinted at a surface rich in organic molecules, similar to some comets and asteroids in our own solar system. As astronomers continued to track Oumuamua's movement, they noticed something else peculiar. Its trajectory through our solar system was not what would be expected from a simple gravitational interaction with the Sun. Instead of following a predictable parabolic path, Oumuamua exhibited a slight but noticeable deviation. This deviation suggested that something else was influencing its motion. One possibility was that the object was outgassing, releasing jets of gas and dust that were subtly altering its trajectory. However, observations of Oumuamua failed to detect any signs of outgassing. No cometary tails or comas were observed, even when the object was closest to the Sun. This lack of outgassing posed a challenge to the cometary explanation for Oumuamua's peculiar motion. If it wasn't outgassing, what else could be responsible for its unexpected trajectory? Despite the challenges, astronomers were able to glean some clues about Oumuamua's composition from its faint light. By analyzing the spectrum of light reflected from its surface, they determined that the object had a reddish hue, similar to some comets and asteroids in our own solar system. This reddish color suggested that Oumuamua's surface was rich in organic molecules, complex carbon-based compounds that are the building blocks of life. The presence of organic molecules on Oumuamua's surface was a significant finding. It raised the tantalizing possibility that this interstellar visitor could be carrying the ingredients for life from its distant home star. The reddish color is thought to be caused by the long-term effects of cosmic rays, high-energy particles that bombard objects in space. The intensity of the reddish hue suggested that Oumuamua had been traveling through interstellar space for a very long time, perhaps millions or even billions of years. The combination of its unusual shape, unexpected trajectory, and reddish hue painted a picture of Oumuamua as a truly enigmatic object. Initially, some scientists speculated that Oumuamua might be a comet. Comets are icy bodies that release gas and dust when they get close to the Sun. This outgassing can create a visible tail and can also cause a comet's trajectory to deviate slightly from a purely gravitational path. Given Oumuamua's unexpected trajectory, a cometary nature seemed plausible at first. However, observations of Oumuamua quickly cast doubt on the comet hypothesis. Despite its close approach to the Sun, no signs of outgassing were detected. Astronomers using some of the world's most powerful telescopes searched for any hints of a cometary tail or coma, but they found nothing. Oumuamua remained stubbornly devoid of any visible signs of cometary activity. The absence of outgassing posed a significant challenge to the cometary explanation for Oumuamua's peculiar motion. As scientists grappled with Oumuamua's enigmatic nature, some began to consider more unconventional explanations. One particularly intriguing possibility was that Oumuamua might be an artificial object, perhaps a light sail sent by an alien civilization. Light sails are a hypothetical form of spacecraft propulsion that utilizes the pressure of sunlight to generate thrust. The light sail hypothesis was bolstered by Oumuamua's unusual shape and its non-gravitational acceleration. A thin, flat object like a light sail would be more susceptible to the pressure of sunlight, potentially explaining its deviation from a purely gravitational trajectory. Moreover, a light sail could be designed to tumble in a way that would produce the observed variations in Oumuamua's brightness. While the light sail hypothesis was highly speculative, it could not be ruled out based on the available evidence. The light sail hypothesis captured the public imagination, sparking widespread speculation about the possibility of alien life. Despite the intrigue surrounding the light sail hypothesis, most scientists remained convinced that Oumuamua was a natural object, albeit an unusual one. They argued that its peculiar characteristics could likely be explained by natural processes, even if we didn't yet fully understand those processes. One possibility was that Oumuamua was a fragment of a larger object that had been torn apart by gravitational forces, perhaps during a close encounter with a star. Such disruptions are thought to be relatively common in the universe, and they can produce fragments with a wide range of shapes and sizes. Oumuamua's elongated shape could be a result of this process. Another possibility was that Oumuamua's unusual motion was caused by outgassing that was simply too faint to be detected by our telescopes. While no visible signs of outgassing were observed, it's possible that Oumuamua was releasing small amounts of gas and dust that were nonetheless sufficient to alter its trajectory. While the exact nature of Oumuamua's natural origin remained uncertain, scientists were confident that further observations and analysis would eventually reveal its secrets. Despite the prevailing scientific consensus that Oumuamua was a natural object, the possibility of an artificial origin continued to intrigue some researchers. They argued that the object's unusual characteristics, particularly its non-gravitational acceleration and its lack of any detectable outgassing, warranted further investigation from the perspective of extraterrestrial technology. Proponents of the artificial origin hypothesis pointed to the fact that Oumuamua's trajectory and behavior were consistent with what might be expected from a light sail. They argued that a light sail could be designed to tumble in a way that would produce the observed variations in Oumuamua's brightness. While the artificial origin hypothesis remained speculative, it highlighted the importance of remaining open to all possibilities when confronted with unexplained phenomena. It served as a reminder that our current understanding of the universe is incomplete, and that we should be prepared to consider even the most unconventional explanations when warranted by the evidence. In the years since Oumuamua's fleeting visit, scientists have continued to analyze the data collected during its brief passage through our solar system. They have also begun to develop new strategies for searching for and studying interstellar objects in the future, hoping to learn more about these mysterious visitors from other star systems. One of the key challenges in studying interstellar objects is their speed. These objects are typically traveling at very high velocities relative to our solar system, making them difficult to detect and track. To address this challenge, astronomers are developing new telescopes and observational techniques that will allow them to scan the sky more rapidly and with greater sensitivity. Another challenge is the limited amount of time available to study interstellar objects once they are detected. Because these objects are not gravitationally bound to our sun, they typically pass through our solar system relatively quickly, often disappearing from view within a matter of weeks or months. Despite the challenges, the study of interstellar objects holds immense promise for advancing our understanding of the universe. The discovery of Oumuamua has opened our eyes to the possibility that our solar system is not alone in hosting visitors from other star systems. In fact, statistical analyses suggest that such interstellar interlopers may be relatively common, with perhaps thousands of them passing through our solar system every year. However, most of these objects are likely too small and faint to be detected with current technology. The realization that interstellar objects are relatively common has profound implications for our understanding of the universe. It suggests that planetary systems are not isolated islands in space, but rather part of a vast and interconnected cosmic web. Objects, including comets, asteroids, and even planets, can be ejected from their home star systems through gravitational interactions and sent on interstellar journeys that can last for millions or even billions of years. By studying the composition and characteristics of these objects, we can gain insights into the conditions that prevail in other star systems and the processes that shape the evolution of planets and planetary systems. As our observational capabilities continue to improve, we can expect to find many more of these objects in the years to come, each one offering a unique glimpse into the vast and mysterious realm of interstellar space. While the true nature of Oumuamua remains a subject of debate, its legacy extends far beyond the realm of scientific inquiry. Its discovery has captured the public imagination, sparking wonder and curiosity about the universe and our place within it. It has also highlighted the importance of scientific exploration and the need to remain open to new possibilities, even those that challenge our current understanding of the cosmos. Oumuamua has reminded us that the universe is full of surprises and that our understanding of the cosmos is constantly evolving. It has also underscored the importance of international collaboration in scientific discovery, as astronomers from around the world came together to observe and study this enigmatic visitor from interstellar space. Perhaps most importantly, Oumuamua has inspired a new generation of scientists and explorers to look beyond our own planet and to search for answers to some of the most fundamental questions about our universe. The journey of scientific discovery is ongoing, and Oumuamua has shown us that the most profound discoveries are often those that challenge our assumptions and expand our horizons.